This is the mu of the shoe lab. Mu of the shoe is an interesting concept. Basically what it is it helps calculate the coefficient of static and kinetic friction, and this is used to ensure the efficiency and safety of athletes and spectators. Some of the definitions include static friction is the force exerted on one surface by another when there is no motion between two surfaces. For example, when you're pushing a couch, you have to exert more force because there's a high static friction. So you have to push beyond the maximum static friction of the couch. Kinetic friction is the force exerted on one surface by another surface when two surfaces rub against each other. Coefficient of kinetic friction is also represented by mu of kinetic friction. It's the slope to the magnitude of the resulting frictional force. The coefficient of kinetic friction is between two surfaces and relates to the frictional force to the normal force. Coefficient of static friction is a scalar that describes the value which describes the ratio of the force of friction between two bodies and the force pressing against each other. For example, the wrestling shoe. The wrestling shoe has low maximum static friction because the wrestlers have to be agile and speedy when they are wrestling their opponent. Another example is the soccer shoe. Soccer shoes require less friction because the players need to jog up and down the field in a fast speed. This would mean that players need to have a shoe that increases static friction and prevents slipping and decreases kinetic friction to move faster. And this is all true, and I have proven it in data in this lab. Football shoes. Football shoes, they require a higher coefficient of static friction because the players, they can't slip on the field. If they slip on the field, that's bad, and they drop the ball and it's a fumble and they screw up and they might lose the game. So that's why American football shoes, they are heavier and they have higher static friction and higher kinetic friction. Hiking shoes have the highest maximum static friction for very obvious reasons, such as hiking the Canadian Rockies. You don't want to slip while you're hiking. That would be bad. Skate sneaker. The skate sneaker reduces the amount of static and kinetic friction because the wheels need to move easier on the ground. You don't want to have high static friction or else the wheels aren't going to move that easily. This shoe is so convenient for the user that you can actually buy to school in these shoes. Basketball shoes, they also have a high maximum static and kinetic friction similar to the football shoe because basketball players, they can't slip on the field, and when they go up for that layup, they can't fall after they get the rebound and take the shot. And this is the data table. The data table shows the highest maximum force of static friction happens to be the football shoe, the hiking shoe, and then the second is the basketball shoe, third is the football shoe, fourth is the wrestling shoe, fifth is the skate sneaker, and it's all here, and it's proven by me. In conclusion, specific athletic shoe boosts performance and increases efficiency. Since each individual shoe has physical qualities that help the athlete, people will be more likely to buy these shoes than any other shoes. And this is part of my advertisement for my project.